Welcome to this video tutorial. In our last tutorial, we introduced ourselves to the concept of flotation in liquids. We explained the meaning of flotation and explored the relationships and mathematical equations which connect a floating body to the liquid in which it floats. In this tutorial, we are going to solve some questions, and since we are going to use the understanding we had in our last tutorial, you can check it out. The link is in both the description and comment sections for you. So now let's take our first question. It reads, an object of mass 3.60 kilograms and volume 6.00 times 10 exponent minus 5 cubic meters floats in a liquid with 1/5 of its volume above the liquid. Calculate the density of the liquid. So this is the question. How do we solve it? First of all, let's put down the details given in the question so that we can analyze it well. We have been given the mass of the object, which are represented by MO, and is equal to 3.60 kilograms. We have also been given the volume of the object, which are represented by VO, and is equal to 6.00 times 10 exponent minus 5 cubic meters. Also, we are told that the fraction of the object above the liquid is 1/5 or 1/5. And in the question, we have been asked to calculate the density of the liquid. We know from our previous tutorial that the fraction of the volume of an object immersed in a liquid is equal to the density of the object, which we are representing by rho O, divided by the density of the liquid, which we are representing by rho L. So from this relation above, we can find the density of the liquid, which the question is demanding. Though the density of the object is not given directly, we can find it using the mass and the volume given. Also, since the fraction of the volume of the object above the liquid is given, we can easily find the fraction of the volume of the object immersed in the liquid by subtracting the 1/5 from the total fraction, which is 1. So we can now find the fraction of the volume of the object immersed in the liquid, and this is equal to 1 minus 1/5, which is going to give us 4/5. So 4/5 or 4/5 is the fraction of the volume of the object immersed in the liquid. Now let's find the density of the object. We know that the density of the object is equal to the mass of the object divided by the volume of the object. The mass of the object is 3.60 kilograms, and this will be divided by the volume, which is 6.00 times 10 exponent minus 5 cubic meters. When we compute this using our calculators, we are going to get 6.00 times 10 exponent positive 4 kilograms per cubic meters. So this is the density of the object, and we already know that the fraction of the volume of the object immersed in the liquid is 4/5. So we can come back to the equation that we wrote first. That is, the fraction of the volume of the object immersed in the liquid is equal to the density of the object divided by the density of the liquid. In this case, the fraction of the volume of the solid immersed in the liquid is equal to the density of the object, rho O, divided by the density of the liquid, rho L. So now let's do substitution. We are going to get 4/5 for the fraction of the volume of the solid immersed in the liquid, being equal to 6.00 times 10 exponent 4 kilograms per cubic meters for the density of the object, divided by rho L, the density of the liquid. Now, when we make density of the liquid the subject, we are going to get 6.00 times 10 exponent 4 kilograms per cubic meters times 5, all divided by 4. And finally, the density of the liquid is going to give us 7.50 times 10 exponent 4 kilograms per cubic meters. And this is the density of the liquid in which the object floats. Now let's take our second question. A hydrometer with a uniform cross-sectional area A floats in a liquid of density 0.80 grams per cubic centimeters. If the hydrometer weighs 100.0 grams and has 12.0 centimeters of its length below the liquid surface, calculate the cross-sectional area of the hydrometer. So the hydrometer is a very simple instrument which is used to determine the density, and for that matter, the relative density of liquids. So now let's put down the details of the question. We have been given that the density of the liquid, which we are representing by rho L, is equal to 0.80 grams per cubic centimeter. Then the mass of the hydrometer, which we are representing by mH, is equal to 100.0 grams. And then the length of the hydrometer, which are represented by HL, is equal to 12.0 centimeters. We have been asked to calculate the cross-sectional area of the hydrometer. And so let's represent the cross-sectional area of the hydrometer by capital A. In order to calculate the cross-sectional area of the hydrometer, we have to factor the volume of the hydrometer. In other words, it is out of the volume of the hydrometer that we are going to get the area. And so let's write that the volume of the hydrometer below the liquid surface is equal to AHL, and this is going to give us 12A. We also know that as the hydrometer floats in the liquid, it will displace a volume of the liquid which is equal to its volume below the surface of the liquid. So we can write that the volume of the hydrometer below the liquid surface is equal to volume of the liquid displaced, which are represented by VLD. Now let's use this relation to find the volume of the liquid displaced. That is, mass of floating hydrometer is equal to the density of the liquid multiplied by the volume of the liquid displaced. And this is a relation that we established in our previous tutorial. So now let's make volume of the liquid displaced the subject. We are going to get the volume of liquid displaced is equal to the mass of the hydrometer divided by the density of the liquid. Let's substitute in the values. We are going to get 100.0 grams divided by 0.80 grams per cubic centimeter. And when you compute this on our calculators, we are going to get 125 cubic centimeters. So this is the volume of the liquid displaced. And as already stated, this volume of the liquid displaced is the same or equal to the volume of the hydrometer that is below the liquid's surface. Now let's remember that the volume of the hydrometer below the liquid surface is equal to 12A. So now that we know the volume of the hydrometer below the liquid surface as 125 cubic centimeters, let's substitute the figures in. We are going to get 125 cubic centimeters is equal to 12 centimeters multiplied by A. Now if we make A the subject, we are going to get 125 cubic centimeters divided by 12 centimeters. And when we compute this once again on our calculators, we are going to get 10.4 squared centimeters. So 12.4 squared centimeters will become the cross-sectional area of the hydrometer. Now let's take our third question. A hydrometer is made of tube of diameter 2.3 centimeters. The mass of the tube and its content is 80 grams. If it floats in a liquid of density 800 kilograms per cubic meters, calculate the depth to which it sinks. This question is a very interesting one. Let's put down the 3 details given in the question. Number 1, we have been given that the diameter of the hydrometer, which we are representing by D, is equal to 2.3 centimeters. Let us convert this to meters, since the density of the liquid given is in kilograms per cubic meters. So we are going to get 2.3 times 10 exponent minus 2 meters, because the C, which is the centi, is a prefix and it is equal to 10 exponent minus 2. So we just substitute its value there. Also, the density of the liquid in which the hydrometer floats, which are representing as rho L, is given as 800 kilograms per cubic meters. We have been given that the mass of the hydrometer, which are represented by M, is equal to 80 grams. Here we have to also convert the mass of the hydrometer from grams to kilograms, because the density of the liquid is given in kilograms per meter cube. And so we have to introduce kilo into our answer. And by introducing kilo and therefore converting from grams to kilograms, we are going to get 80 times 10 exponent minus 3 kilograms. We are told to calculate the depth to which the hydrometer sinks. And the depth cannot be obtained alone, but could be obtained from the volume. And so we have to relate the depth of the hydrometer to its volume. And with this, we know that the volume of the hydrometer is going to be pi r square h, because the hydrometer is cylindrical in its appearance. And so the volume of a cylinder is the same as the volume of the hydrometer, which is pi r square h. And since you have been given diameter instead of radius in the question, let us transform pi r square h so that it will have diameter in it. And this is going to give us pi d square h divided by 4. So now let's substitute the values. The volume of the hydrometer is going to be 22/7, which is for pi, multiplied by 2.3 times 10 exponent minus 2, all squared, multiplied by the height, that is the depth to which the hydrometer sinks, which are represented by the h, all divided by 4. When we compute this on our calculators, we are going to have 4.16 times 10 exponent minus 4 h. So this is the volume of the hydrometer which is sinking in the liquid, and it is expressed in terms of its height, which is also sinking in the liquid. So now we can find the volume of the hydrometer inside the liquid, and when we find it, we can come and substitute it into this to find the height which the question is asking us to find. And to do this, we know that the volume of the hydrometer below the liquid surface is the same as the volume of the liquid which will be displaced. So if you know the volume of the liquid which is displaced, it will be the same as the volume of the hydrometer below the liquid surface. So let's find the volume of the liquid displaced. And with this, we know that we have to relate it to the mass of the hydrometer. We established this from our previous tutorial. We are going to have mass of the floating hydrometer is equal to the density of the liquid multiplied by the volume of the liquid displaced. So if you make volume of the liquid displaced the subject, we are going to get volume of liquid displaced is equal to the mass of the hydrometer divided by the density of the liquid. And when we substitute in the figures, we are going to get 80 times 10 exponent minus 3 kilograms divided by 800 kilograms per cubic meters. And this is going to give us 1.0 times 10 exponent minus 4 cubic meters. So it means that the volume of the hydrometer below the liquid surface is 1.0 times 10 exponent minus 4 cubic meters. So let's now substitute this into the relation that we had earlier, which is the VH is equal to 4.16 times 10 exponent minus 4H. And this is going to give us 1.0 times 10 exponent minus 4 cubic meters is equal to 4.16 times 10 exponent minus 4H. Now I want to find H, so we divide 1.0 times 10 exponent minus 4 cubic meters by 4.16 times 10 exponent minus 4 meters squared. And when we compute this, our H is going to give us 0.24 meters. Now let's take our fourth and final question for this tutorial, and it relates flotation to relative density and density. Let's take the question. A simple hydrometer of mass 50 grams floats in a liquid of density 1.4. Calculate the volume of the liquid displaced by the hydrometer, and the density of water has been given as 1.0 grams per cubic centimeters. So let's see how we are going to solve this question. We have been given that the mass of the hydrometer, which we are representing by M, is equal to 50 grams. The relative density of the liquid, which we are representing by RDL, is 1.4. And the density of water, which we are representing by rho W, is equal to 1.0 grams per cubic centimeters. The question has asked us to find the volume of the liquid displaced by the hydrometer. And to find the volume of the liquid displaced by the hydrometer, we have to use this relation, which is mass of floating hydrometer is equal to density of the liquid, which are represented by rho L, times the volume of the liquid displaced, which are represented by VLD. So let's make the volume of the liquid displaced the subject. We are going to get the volume of the liquid displaced is equal to the mass of the floating hydrometer divided by the density of the liquid. Since we know the mass of the hydrometer, our task will be to find the density of the liquid. And to find the density of the liquid, we have been given the relative density of the liquid. The relative density of the liquid is equal to the density of the liquid divided by the density of water. Now let's make density of the liquid the subject. We are going to get density of the liquid is equal to relative density of the liquid times the density of water. Let's substitute the figures. We are going to get density of liquid is equal to 1.4 times 1.0 grams per cubic centimeters. And this is going to give us 1.4 grams per cubic centimeters. So finally, we can find the volume of the liquid displaced by the hydrometer. And this will be equal to 50 grams divided by 1.4 grams per cubic centimeter. Computing this on our calculators, we are going to get 35.7 cubic centimeters. So this is the end of our tutorial today. Thank you very much for watching this tutorial. We will see you in the next tutorial on upthrust in fluids. Don't forget to subscribe to our channel, share the videos and like it as well.